No, you won't really need graph paper for this. Okay, but our second option when we get a 0 on bottom is to actually use a graph. They'll help us. We're actually not going to use a whole lot of graphs right now. And let me just be sure that I tell you this. If you use your calculator and it has a graph on there, make sure that you are smarter than your calculator, okay? Because sometimes you'll see some things on the calculator and you'll say, oh, well, it must be this, when you haven't used the calculator properly, or there's something that the calculator can't exactly show you. It doesn't have a way of, like, depicting it on a graph or something like that. And so you're sitting here and you think that you've just, like, nailed the answer. You got it. Because, look, there it is on the graph on the calculator. Completely oblivious to the fact that you didn't, like, put something into the calculator properly, or that the calculator is, like, for example, when you take the square root of x, right? Whenever you do the square root of x and you graph the graph of the square root of x in the calculator, it only gives you the top line. But hopefully everybody knows that if you graph, the square root of x, it actually looks something like this. Okay? But the calculator only gives you this. Okay? So if you're using the calculator, you need to be smarter than the calculator to understand that there should also be a line down here, and there are multiple points on the graph you could be at. So there's my warning for relying on the calculator too much whenever it comes to these problems. Okay. So the sine of x over x as x approaches 0, is this a problem? For some people. Well, what's the first thing we want to do? Plug it in. All right, so put this in. So sine of 0 over 0. Yeah, it just depends on whether or not you actually know your trig functions. You may think that you hit a home run with this problem and you know exactly what's going on, or you may realize that you have an actual issue here. What is the sine of 0? 0 over 0. Remember that's special. It's a maybe. It can be a lot of stuff, right? There are a lot of different things that can happen with a 0 over 0. Okay, so we can use a graph. And so if you have a calculator, hopefully you do. You can put this in. Now let me make sure that I have my calculator set up properly. I'm actually going to go to the mode. And I'm going to make sure that my calculator is in radian mode, and I am right now. So just go to radian and hit enter. If you're not in radian mode and you try to graph a trig function on your calculator, you will be severely disappointed because absolutely nothing will end up showing up on there. And where's my graph? Well, if you're using 360 degrees, then your calculator would have to go from 0 to 360 on the scale, but for you to be able to see the entire thing. But radians, how many radians are there in a circle? In an entire rotation? 2 pi. So that's like 6.28. So in order for you to see the entire thing on a radian graph, you just need to go from 0 to 6.28. If you're in degree mode, your calculator has to go from 0 to 360 for you to see the entire graph. You see the big difference there? Okay, so when you're graphing trig functions, you always want to make sure you're in radian mode. So let me go to y equals, and I'm going to put this in. I'm going to use alpha y equals, and then hit enter on number 1. It makes this nice little fraction bar for me. I don't know if you guys are familiar with that or not. Okay, but all I did was use alpha, and then the y equals button, and hit enter. And it creates a fraction for me I can write on top and bottom. So on top, I want the sine of x. And on bottom, I just want x. I'm going to graph it. There's a fast x right up here at the top, right below mode. Yeah, so when you're in here for y equals, okay, hit alpha and the y equals button, and it'll give you this little menu. And then hit enter right there on that very first one. And it'll actually let you create a fraction by writing top and bottom. Usually you have to keep the top, especially if you have multiple operations going on, you have to have like parentheses for the top part of a fraction and then parentheses for the bottom. So now we're just using sine of, and then there's a little button right here you can hit that gives you x automatically. Closing the parentheses and then put an x on bottom. And then I'm just hitting the graph button. This thing will come up. Go ahead, Lexi. Your window should just be normal right now. So you can just hit zoom 6 and it'll give you a normal window. Just put in sin x divided by x right now. It'll still work for this one. It's especially like more complicated fractions where that's helpful. And I just need to update the software on that calculator and it'll work. All right, so we're really concerned about what's happening around 0, right? So I'm just going to hit zoom and then 2. And I'm going to and then to hit enter once it comes back, and this thing will zoom in for you. Okay, so hit zoom and you can press 2 or you can go down to the 2, and then when you come back to the screen you actually need to hit enter. Okay, so it hasn't zoomed in yet. It brings you back to the screen, and then when you hit enter it zooms in for you. Now, from looking at this graph, as x approaches 0, what would you say the answer is? Yeah. 1. You sounded so confident, Lexi. Okay. No, it's a 1. That's right. So you can follow it from the left, right, and you can see it's heading for, 1, and then follow it from the right, and it's heading for 1. So it is 1. But I was going to say, but if you actually put a 0 in there, so I don't know if I can zoom in again. Let me try and see what this thing ends up looking like. I want to zoom in on this spot. The calculator is probably not going to show you much, so I'm trying to zoom in on that one spot. It looks like there's a straight line going right through there, right? And there's no problem. Everybody do this. Hit second graph and come up with a table, okay? And you can see when I went to my table, immediately at 0, it says error, right? Everywhere else, I got numbers, no problem, okay? And so on the graph, it may look like the line goes straight through that point, 0, 1, and it actually exists there, but in reality, it doesn't. And it's not until you go to the table that you can see that there's actually nothing there. If we graphed it, there would just be an open circle there. This is actually what the graph looks like, okay? You see, this is from Wolfram Alpha, and so they actually put circles in their holes and stuff like that. So the limit exists, but when you get there, there's nothing, right? It says there's an error at 0, right? What's the limit, right? Because the limit is all about the the limit is all about the approach, right? So what the graph is doing when you go to the table, it's not showing you limits. It's showing you what's actually at the point. And so when you see the table and it says error, that doesn't mean that there's no limit. That means there's nothing when you actually get there. But remember, the limits aren't concerned with what happens when you actually get there. It's just the approach. Yeah. So it approaches 1. Okay. All right. So thank you for ducking Braden. Yeah. But that's not how the thing records anyway. It's recording this screen, like you blocking the projector. Look at that screen over there. Like that screen is not videoing the projector. It's sending a signal, a picture to the projector, and the projector is putting it on the whiteboard. Girls, sorry, but Braden's in the class and he's doing funny stuff, crawling around on the floor. Poor Braden. Luckily for him, there's no test to be. No. All right. So the answer is 1. Now, I want to get to something that's really, really important here, okay, so that you can understand why this answer is 1. And I'm not going to do like some great mathematical proof. I'm just going to try to put a few things in front of you, almost like evidence, okay, just kind of some evidence for why this thing actually ends up being 1. Okay, so if you think about the graph of the sine function, Okay, remember graphing sine. It goes through the point 0, 0. Okay, and it makes this like really awesome curve. Okay, so whatever. But not a good picture. But this is what's important, is what's happening right in here. Like, because what we're talking about, okay, is what's happening whenever our x value is really, really close to 0. Remember, this was the limit as x approaches 0. So I can't say this enough. This is what happens when you're really, really close to 0. Don't use, if it says sine of pi, don't use this. This is only what's true about the sine function when it's really, really close to what? 0, okay? It cannot be overemphasized here. It could be underemphasized, but not overemphasized. Now, what actually happens, so let me just imagine that we're zooming in now, okay? And so we're talking about the sine function. We know it goes through 0, 0, and it has this like nice little shape, okay? So here we go, and all I'm trying to do is act like I zoomed way in on that, and we're still just talking about this space right here. And then if I zoom in on, where I have that circle right there, so imagine that I zoomed in on this first circle, and that's kind of how I came up with this, with these lines. And now let me zoom in on that one. And so if I zoom in on that one even more, then I would get to 0, 0, but I would have something like this. Okay, and if you zoom in on the sine function a whole lot, so does everybody see how, I started with the curve, but I zoomed in, so you have, a little bit of curve in these left. I zoomed way in, and so you can see on this graph, I've zoomed in already, and so I just have that little bit of curve I was talking about. But now I'm zooming in even more, right? And if I zoom in even more, you can see this thing really starts to look like what? Yeah, if you zoomed all the way in on the sine function, what you would end up with is something that almost looked like a straight line, where this would be like 0.000. Okay, so all of these points are, they're really, really small. We zoomed way in. But this is actually what happens in a sine graph. I mean, if you got really, really close to 0, and you can actually do it on your calculator if you want to. We could all go to y equals, so humor me, go to y equals, clear this thing out, and just graph sine of x. I'm going to hit zoom 6 to get my window back to where it was before, okay, because it's zoomed in from where we were earlier. So if you just hit zoom and then 6, it should take you back to the normal spot. You can see the sine graph. Now I'm going to zoom in, so I'm going to use zoom 2 again and then press enter. And I'm trying to zoom in on that spot right there. And I'm going to do it again. Zoom 2, enter. And don't worry, I am. All right, zoom in. One more for good measure, right? Zoom in. Right? And so now when we get really, really close to 0, you can see that basically the sine graph just creates a straight line whenever you're really, really close, right? If I was going to ask you for a function right here, if I just ask you, for y equals, what would you say the function was, right? What function would give you something that looks like that? Y equals what? 2x plus 7, 5x plus 3, what? X. That's exactly right. The y value, this graph right here, the y value is equal to the x value. If you start following this line, if let me do, I'm going to hit the trace button here so that I'm actually on the line, and I'm going to trace this line. Look at the numbers, okay? Hit trace and look at the numbers. Look at the x value compared to the y value. Right now when I'm on that line, so you got to hit trace, okay? So hit the button trace, and you can move left and right. And you'll see that with the sine function, when you're really close to 0, if I move to the right, my x value is 0.004155559. My y is 0.0041555 7. Okay, but they're extremely close to one another. Do you get what I'm saying? Okay, so now let me come back a little bit. And now they're both, 3, 0, 0, 3, 3, that matches. 2, 2 matches. 4, 4, 4, 4. And now the two, before the last numbers were 9 and 7. Now the last two numbers are 6 and 7, right? So before it was 5 and 7, or 9 and 7, it was off by 2. Now the last two numbers are just off by 1. Okay, and now here they match, right? The x value and the y value have become exactly the same whenever I get down to 0.002493335, okay? And as I get closer and closer, you'll see that they're exactly the same all the way until I hit 0, okay? But this is the graph. I haven't changed the graph. This is still the graph of the sine function, right? So here's my point. Whenever the sine function is really, really close to 0, write this down. Whenever the sine function is really, really close to 0, when sine is really close to 0, you get out what you put in. All right, so whenever you're really, really close to 0 with the sine function, you get out what you put in. Remember, right now we're using the function sine of x. So what are we actually plugging into the sine function? Especially at this point right here, what's our x value? Yeah, it's the same, right? So here's our x value, 8.3112 e to the negative 4. And then what do we get out? The same exact thing. So what ends up happening is whatever we put into the function is the same thing we get out, only when we're close to 0, only because when you're really, really close to 0, the sine function actually operates just like a straight line, like the line y equals x. So whatever x value you put in, the sine function just gives you that exact same number right back out when you're close to 0. Okay? So is it any surprise then, now knowing this about the sine function, that when you're really close to 0 and you do the sine of x divided by x, you get 1? Because what does the sine function give you? What you put in. What did you put in? X. So in reality, since you're operating really close to 0, if you take the sine function, it's going to give you whatever you put in there, which was x. And what was on bottom? What's any number divided by itself? So sine of x over x ends up being 1, right? Because in reality, you say, oh, well, 0 over 0 still. Well, in this case, it's a little different because can't, if you're doing algebra, any kind of algebra, this would just turn into a, x over x. You would cancel the two x's, and all you would have is the limit as x approaches 0 of 1 equals 1, okay? We'll talk more about the algebra aspect in a little bit. Let me go back to my graph. I just want to do something else. So I'm going to go into y equals now, and I'm going to change this from x. I'm going to change it to 3x. What does 3x stand for? Yeah, what does it mean? What does 3x mean? 3 times x. That's exactly right. Okay, so 3 times x. So what I'm going to do now is, what am I putting into the sine function? My x value multiplied by 3, okay? So let me go back to my graph now. Hopefully I should still be able to see it. Okay, here we go. I can still see it. Good. I'm not going to zoom in. I'm going to trace, though. Okay, let me move to the right one. Okay, and now you can see that my x value is 8.3112 e to the negative 4, but my y value is different. Why is my y value different? Okay, very good. We're still close to 0, but what I put in was not just my x value, it was my x value what? Times 3. So if these things were really going to match now, I would need to be able to do what? Take the x value and do what to it? Multiply by 3, and then I would get the Y value. Okay, so take, it's a -4. So put into your calculator 0.000. So 3 zeros, and then the 8. So 0.000831112. And then multiply that by 3. Okay, so now you have a 6 instead of a 5 at the back is the only difference when you did that. So did it give you what you put in? Absolutely it did, because the difference now is that we didn't just put in an x, right? We put in 3 x's. So what it gave us, we're still really close to 0 because we're still super zoomed in on that same graph, right? So what it gave us was 3 x's because we put in 3x. So it gave us out whatever we put in, okay? That's an important concept. What number were we really close to? Our x value was really close to what? 0, right? The x value has to be really close to 0 in order for that to work. So now I ask, what is this? Hang on. Go ahead and write it down. Anybody think they know? I need to give you a minute so you can think about it. Everybody's working with the calculators. Think you got it? Or you want to check first before you start saying it out loud? Yes. You want to explain? Yeah. The limit as x approaches 0, and all he's saying right here is, if you look at that, we're really close to 0. So here's what's happening. If we're really close to 0 and you put 2x into the sine function, what are you actually going to get out? 2x. So this is really just like having what's on bottom. Cancel your x's and you get what? Ta-da! Right? That's it. That's the graph of what that last one would look like. See if you can figure this one out. Work it the same way. All right, does anyone know? Go ahead, Taylor. Is it 2? Well, let's see. What's this going to act like? Cross out your x's, and it's 6 divided by, okay, so you have the limit as x approaches 0 of 2, right? You kind of simplified this thing down to just being 2. So now you take your 0 and you do what with it? Plug it in, right? But is there anywhere to plug it in? No, so the answer is just 2. You're done. Right, right, yeah. Uh-huh, that's it. But if you went to that little spot right there, it would be y equals 2. But this is 20 up here. Okay, so let's go. It's because whenever you get away from 0, everything changes. Remember, it's just around 0 that ends up working. Mm-hmm. This one. Do you remember it, Cameron? Kristen, do you remember this one? One minus cosine squared would be the same as sine x. Yeah, this is a different one. That would be a perfectly legitimate thing to do, though. If it was cosine, 1 minus cosine squared, it would be the same as sine squared x, and you can work it out that way. Okay. This is one you have to memorize. Okay. So what you can graph it, and then this is what the graph would look like. Okay. So you can see that as x approaches 0, the y value is approaching 0. But this is one you just kind of have to memorize. Okay. So 1 minus cosine x over x, 0. Is there another one? I can't remember right now. I'm about to give them this other stuff, though. It's probably what you're thinking about is this next slide. All right, so here are just important trigonometric ideas. Yes, I think I can. They look hard. Don't be intimidated by stuff that looks hard. Yeah, they're actually not too bad. You've actually just done all of these for the most part. Okay, so sine of x over x is 1, and then if you flip it, does that really make a difference? No, it's still just 1. So that's all those first ones are about, right? So sine x over x is 1, and so x over sine x is 1 as well. Now, the limit as x approaches 0 of sine of ax. So there's some number in front of x, like 2. And then on the bottom, it's like the one where we did where it was 2x over 5x, right? A and B would just be some number. Don't let those confuse you. So if it was the sine of 3x over 4x, then the answer would be 3 over 4. That's all this is trying to communicate, okay? And in like manner, if you flip it, okay, and you did the sine of 4x, or sorry, if you did the limit as x approaches 0 of 4x over the sine of 3x, then the answer would just be 4 over 3. But remember, every single one of those are approaching 0. It's all about the limit at 0. That's where you can do the trick where the sine function is going to give you whatever you put in. And the last one is 0. We've just talked about it. That's one you just kind of have to memorize. All right, so take out your textbooks and go ahead and flip to page 99 and do numbers 30 through 42, the even. So 30 through 42, the even. Just in your notes, And then those of you watching on video, this is your homework assignment. So you may want to go ahead and do that one as well. So classwork is here, homework is here.